Pre-calculus pre-recording video. This is about logarithmic and exponential equations, which is in section 5.6, but we will connect it with 5.5 as well. So these are the agenda: solving equations by taking the logarithm of both sides and by cancelling logarithms. Then discussion on domain of logarithmic functions, change of base formula. So these are the agenda for this lesson video. Now, properties of exponent versus properties of logarithm, how they are connected. As you know, basically they are inverse of each other, so they are connected. Now, how it works: if you have a to the power s equals to m, a to the power t equals to n, in the logarithmic format, log a base m equals to s, log a base n equals to t, then how they are connected. First of all, as you know, in the exponent, we have a to the power s into a to the power t equals to a to the power s plus t. We say it this way: when the base is same, power addition. If the base is same, then power addition. Power and power addition. Okay. In the logarithm, if they give us something in multiplied form, suppose m into n, then it becomes addition. Okay, log a base m plus log a base n. How it works, an example is given here. Let's say you have log 2 base 256. Log 2 base 256. Without looking at this side, if you solve this part, log 2 base, this part, you will notice that the solution is actually 8. If you look at this side only, this equal to actually log 2 base 2 to the power 8. Okay, then 8 comes here, log 2 base 2. So you know 2 base 2 equal to 1. This is 1. So this equals to 8. Okay, so log 2 base 256 equals to 8. Now, how it works in this way? Okay, see this, we can write this thing log 2 base 256, this thing we can write it in 32 into 8. 32 into 8 equals to again 256. Then based on the rule, if we see something in multiplication within log, we can write it into addition. So it will become log 2 base 32, then plus log 2 base 8. Okay, then this thing we can write log 2 base 32 means what? 2 to the power what? So 3, 4, 5, 2 to the power 5. This means 2 to the power 5. Then plus log 2 base 8 means 2 to the power 3. 2 to the power 3. So this 5 will come to this side. So this log 2 base 2 will be here. Then plus this 3 will come to this side. Log 2 base 2 will be here. Then see, 2 base 2 equal to 1. 2 base 2 equal to 1. Then 5 plus 3 remains. 5 plus 3 equal to 8. Okay. So basically this equals to 5. Then plus this equals to 3. And 5 plus 3 equals to 8. So this is how this formula works here. This is how this formula works here. And for the exponential part, why it works, this is actually relatively even easier. Suppose if you have 2 to the power, let's say simple something, let's say 2 to the power 1, 2, 3, 4, let's say 2 to the power 4. So 2 to the power 4 equals to what? So 2 to the power 4 equals to 16. Okay, now if I break it down into a smaller part, let's say I want to write it like 2 to the power 1, 2 to the power 1 into 2 to the power 3, this 4. We just break it down, then it will become 1 plus 3. So this equals to actually 2, and this equals to 2 to the power 3. 2 to the power 3 means 8. So this equals to again 16. Okay. So if we just break it down, it works. Okay. The previous line is 2 to the power 1 plus 3. 4 means 1 plus 3. Then it will become 2 to the power 1 into 2 to the power 3. Then they gives us the same answer. So the point here is, if you do the experiment with the different numbers, they will all work here. Okay, they all will work. And we have examples here with each of the situation, with each of the cases. When it is division, when it is a to the power s divided by a to the power t, it becomes subtraction. Same thing goes here. If it is division, it becomes subtraction. The proof is, or how it works, is given here. Then power multiplication. In the logarithm, this power actually comes to the front, this power. The reason is the number of copies actually this represent, that is the reason here. And then if a to the power u equals to a to the power v, then u equals to v. This is one of the important rule that you will be using if you try to solve exponential equation. Same thing goes here. If o equal to p, then you can write log a base o equal to log a base p. This 4 number is pretty much like rigorously important in solving the logarithmic and solving the exponential equation, because it actually connects two sides of the equation. What does it mean? It means if something is given to you, 64 equals to 2 to the power twice x, let's say something is given to you, then sometimes we say that, hey, multiply it by log in the both side. Log, let's say 10 base, log, let's say e base, log, let's say 2 base, 3 base, whatever it is. And the reason we can do it, this 4 number rule here, that allows us to do that. We can take it in the both side. And sometimes if we say, hey, if the base is same, then power equals to power. This is the rule why it permits us to do so. Okay, so these rules are pretty much important. You will have to know them quite well. The output of a logarithmic function is exponent. So if you can add exponents, you can add logarithms, etc. This is the core reason why we can do from here to here. Okay, we can, or why they follow similar pattern. Okay, this is the core rules. So here, if you look at this, if o equal to p, this rule, 6 to the power x equals to 4 to the power x plus 1, then we can actually take ln in the both side. So we take ln in the both side, then we have this. Then x equals to ln 6, x equals to x plus 1 equals to this power comes to this side, and ln 4. Then we can continue the calculation, because ln 6 they have some specific value, ln 4 they have some specific value. Then we can connect it. We can put the value. We can find out the x from here, because this is just a number. Ln 4 is just a number. Ln 6 is just a constant number. Okay. Same thing goes here. If you have ln in the both side or log in the both side, then something here, you can actually cancel them out from the both side. Okay, so this is true. We can cancel them out from the both side. These are like basic concept for solving the equations. So one of the example is here, where we can apply the rules that we have seen so far. 3 to the power 1 minus twice x, 4 to the power x. How can we solve it? So the rule is, see, if you have something here and here, and you do not have a way to solve it, you do not know what to do, then one of the ways is to take log in the both side. Okay, multiply it by log. Now here we multiplied by log 10 base, because we know down the road there will be something where maybe we will have to use the calculator. So since log 10 base is calculator base, and calculator actually knows this, that's why taking log base is most of the time is easier for us. especially if we do not know what to take. Then 1 minus x will come to this side, x will come to this side, this 1 minus x comes here because this is power goes to the front, okay, for the logarithm. Then we have this equals to this. Then this is 1 minus twice x. This is log 3. So we can distribute this for 1 and for twice x because it is a multiplication, right? In a multiplication, we can actually do it. Suppose if a into x plus 1, then a into x, then 1, 1 into a. So we can distribute it. So log 3 and log this. We multiplied log 3 with 1 and log 3 with twice x. Okay. Okay. Then what do we do? See, this is log 3. This is twice x log 3, x log 4. So why not bring all the x related logarithm in one side? Because what is our target? Our target is to find out x equals to what? Target is to find out x equals to what? Okay, so that's why we bring all the x in the one side. Then we take x common. We take x common from the from all of them. See, there is x here, there is x here. So take x common. Then you will end up with log 4 plus 2 log 3. This x is common there. Then, just like the rule in the algebra, we can send it to the other side. So it will become division since it is multiplication this side. This is one way to look at it. Another way to look at it is now divide both sides by log 4 plus 2 log 3. Then you will have it. Now, how from this thing it comes? Just we use a normal calculator. Okay, we use a calculator. Log 3 divided by bracket. Very important thing, by the way. When you do it in the calculator, you must give a bracket in the calculator. So you will write log 3 divided by bracket start log 4 plus 2 log 3 bracket close. Then you will get the answer. If you don't give the bracket, answer will be different. Okay, so this is how we can solve it. This is another similar math. Give a try to solve it. Same way. Okay, same way. This one you have seen in our another recording, and also in the class also you have seen this. Just whatever you say in the logarithm, the same thing goes inverse in the exponent, or whatever is in the exponent, this thing goes to the logarithm. What does it mean? This means that the domain of the logarithm will become the range of the exponential. In other words, the domain of the exponential will become the range of the logarithm. Okay, so see this here, domain of e to the power x, all real number. This has become the range of ln x. The domain of exponential has become the range of logarithm. The range of exponential has become the domain of logarithm. Okay, this is how it changed. See, the y-intercept is none here. In this case, x-intercept, this is x-intercept is none here. In this case, that thing has become y-intercept. In this case, y-intercept is 1 here, and in the logarithm, this has become x-intercept. So basically, they swap, they swap. Now, this is true even for the asymptote here. The asymptote for the exponential is horizontal asymptote for exponential. So this is the exponential horizontal asymptote. That means if you swap it, then this will become the vertical asymptote for the logarithm. So the same thing will become vertical asymptote for the logarithm because they are inverse of each other. That is the reason. Okay. That is the reason. So they will, now why we are discussing it, this is tricky. This is kind of an weapon for you. Do you understand? This is kind of a weapon for you. Now, why it is a weapon? Let me give you a hint. And the hint is, sometimes you may face in the future, some logarithmic function where it is tough to solve, or it is tough to find out what is the domain of this logarithm. Then you can just convert it to the exponential, then find the range of the exponential. Then you will be like, okay, this range will become the domain in that part. Do you understand? So this way you can actually solve it. Or vice versa. Suppose suppose some exponential seems tough to you, then you can, if you are expert in logarithm, you can convert it to the logarithm and find the opposite of it. And then actually this will help you to solve it, because they will always be true. Okay, this is how they will change. So what is the domain of all of this logarithmic function? Look, look, the rule is this x plus 1. In the definition of logarithmic function, we said that this x has to be positive. X has to be positive, and the reason is here. X has to be positive because this graph never goes back in this side when the function is log a base x. And this graph never goes back there. So that means this x plus 1, this has to be positive. So if this is positive, how do we do it? How can we solve it? See, x plus 1, this has to be greater than 0. Positive means greater than 0. So that means x has to be greater than minus 1. So this is the domain of this number 1. Okay, this is the domain here. Now this one, x plus 6 has to be greater than 0. Then x has to be greater than minus 6. Then x minus 4 also, there is two value here for two number. X minus 4 has to be greater than 0. That means x has to be greater than 4. Now you see there is a problem here where you have two conditions. You will have to look at, if you combine both of them, what is the remaining. Okay, and actually I can show you, this is little bit lengthy, but let me show you the lengthy process. In fact, the answer will be x is greater than 4, because if you consider x is greater than 4, then actually this is also included there. So see, you can consider the number line. Suppose minus this is let's say minus 6 is here, this is minus 6, this is 0, and let's say this is 4, and this is the positive end, this is the negative end of the number line. You know the number line 1 2 3 4 5 6 7, this side negative 1 2 3 4 negative, all the negative is this side. Now what it is saying is x has to be greater than, first of all look at this, x has to be greater than 4. That means this is 4, x has to be this side greater than 4. Then this condition says x has to be greater than minus 6. So this is minus 6, x has to be greater than this side. So if you consider from 4 to this side, then actually both of the arrow is included. So only if you write x is greater than 4, then actually this actually fits in both of the condition. Now why x is not greater than 6? Because if you just only consider x is greater than minus 6, this part, then this is only true for this part, not for this part. Okay, this is not true for this one. But if we take x is greater than 4, then it is true for this part and this part, for both of them. As you can see here, both of them it is true. So we have to, if you say multiple thing, then we have to come to a position where both of the conditions are satisfied. Okay, so this is the way we can calculate it. Let's check the answers. Answers actually written here. Let's keep it there. So these are the answers. See, x is greater than minus 1, x is greater than 4, this one is easy, this one is simple, log 3 base x, so it has to be x is greater than 0, because you know, if it is just only log 3 base x, then actually this has to be, x has to be greater than 0. As you know, this is the definition of logarithmic function. This 2 is just a number which where we will multiply it, with the with the mm, with the whatever the value we get here. This is log 3 base x square. Interestingly, this one is different. This is only x cannot be equals to 0. The reason is where you have x squared, there actually you can put the negative number inside the x, because this x squared thing makes it positive. Suppose you have 4. Suppose you have 4 x equals 2. So it becomes, when you have a square, then it becomes 16, and if you put minus 4, this also becomes 16. So negative number and positive number both fits in this function, in this equation for number. So that's why we are not saying that x is greater than 4, because that's not true here. It has the power is even, and even power actually can take it. Okay, and x is not equal to 0, because that's the one of the fundamental rule. If x is 0, this becomes 0, and 3 to the power what equals to 0, we do not know. Nobody knows. Okay, 3 to the power what equals to 0, nobody knows. So that's why 0 cannot be possible. Actually, this is true for all the logarithm. This value can never be 0, 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 this value can never be 0. Okay, 0 is not possible. 0 is not possible. Now you can say, sir, you did not say that when you discussed it. Actually, when you said that x is greater than minus 1, basically we avoided that 0, because if x equals to minus 1, then it becomes 0. So we said x is greater than minus 1. If x equals to minus 1, then minus 1 plus 1 equal to 0. But we avoided by saying x is greater than this. We said x plus 1 is greater than 0. See? Greater than 0. It means it is not equal to 0, not negative number also. But it can take, last one, 4 number only can take negative number. The reason is there is a square here. So you can try to solve these maths. Now there is a important, I think some of you may have noticed that you can say, oh my god, why this is x squared, this is 2 log 3 base x. So the 2 I can bring here, then it becomes x squared, then this and this is similar. This is kind of tricky, and they are not actually same in the logarithm when it is given. Okay, see this, why it is not same. Why it is, suppose log 3 base x square equals to 4, and the solution is the domain of this variable x is real number except 0. Why it is so? See this here. Suppose if we have log 3 base x square equals to 4, then x square equals to 3 to the power 4. Just the change of logarithm to exponent, it becomes 81, and x equals to becomes, since there is a square, so plus minus will come here. Okay, and actually this plus minus of 9 is valid here if you put, okay, plus minus is valid here. But if we bring this 2 to this side, then 2 goes to the other side. So 4 divided by 2 equals to 2, then log 3 base x equals to 2, so x equals to 3 squared, that means 9. So in this kind of situation, we get x equals to 9, only one answer. But for the same math, we get two answer in the left side here. So which one is correct? Correct is this one. If there is x square, then we should not bring this to the other side, because there is like positive negative possible here when there is a square even number. Okay, so so we will have to be little bit careful about this. Yeah, so we will have to be a little bit careful when the power is even here. Okay, because the meaning changes. And this is a lot, this is a subtle thing that we will have to be careful. You can say, sir, oh my god, this is tricky. Yeah, that's true, and we will have to be, this is the one of the thing that in logarithm we will have to be careful with, since they say it explicitly here. or they mention it to be careful about that. So we will have to be careful about that, because the reason we can see here, they do not fit. You understand? They do not fit. Here actually you can put negative or positive, both of them. But our function says only positive value. That's not true. Okay, if we solve it in the other way. So the conclusion here is, if there is even number power here, we'll have to be careful a little bit. Change of base formula you already have seen a bit. So if we have log a base m, the formula becomes log. This is so important, that's why it is coming again and again, back and forth. And we said that actually this will come back again and again, because this is one of the very important rule that we need while solving. So why it works? Suppose if we have y equals to log 2 base 9, then how can we convert to it as an exponential? So it will become 9 equals to 2 to the power y, right? Now we can take log in the both side or ln in the both side, right? Then this y can come in the front. Then it will be ln 9 divided by ln 2. So we can then find out the answer. Now in this line, in the second step, if we multiply it by log 10 base, or just only log this log button, then actually it will become y equal to log 9 divided by log 2. Answer will be same, 3.177. So don't worry about that. They will be the same answer. This is where you will be using this formula. Try to find out the answer of these questions. Okay, here we will need to find out the value of this. Of course, you will have to use the calculator here for sure. See, base change formula we will have to apply in this kind of situations. Actually, this is the example you can use, just like this equals to ln. This is just a repetition of the same concept, so that this solidifies in your mind. This is again from this exact same formula. Another example here. Okay, another example here. So what is going on here, if you try to look at it, is log 4 base x is given here. So in this case it is log 2 base, in this case it is log 4 base. So maybe if we convert this log 4 base to log 2 base, then maybe it will be helpful for us to solve this. That's why we are converting it to log 2 base. Okay, so log 4 base x equals to log 2 base x log 2 base 4. See, 2 base same, x divided by 4. This x divided by 4 here. Then once we have it, then we actually can continue. This log 2 base 4 equals to 2. So we have 1 by 2. Then it goes to this side, it will become square root. Then it becomes a square root. And if we want, then we can put it here and go for more thing, just more calculation if it is needed. Because then log 2 and log 2 base is same, then basically if it is division, we can, if it is subtraction, we can do the division. If it is addition, we can do the multiplication, and this and that we can easily do. But one of the important thing here is, if you have different base, we will have to convert it to the same base, so that the math is solvable. Okay, this is an application math from the book. A population model. A population model. The resident population of the United States in 2008 was 304 million people and was growing at a rate of 0.9% per year. Assuming that this growth rate continues, the model Pt equals to 304 into 1.009 to the power t minus 2008, because from the 2008 they started, represent the population P in million years, in the in million of people in year t. This 1.009 came from 0.09%, because already there was 1, then plus the 0.09%. Okay, this thing came this way. Let me show you that how they get this formula. This thing came this way. The rule is p into 1 plus r to the power n. Okay, so p, then 1 plus r is 0.9%. N equals to this year, whatever it is. Okay, I'm just showing this part inside how it came. So 1 plus 9%. So 0.9 divided by 100, okay, to the power n. So if you calculate it, you will get this part. This part if you calculate it. This is how they make this kind of questions and formulas. Okay. All right, so now they ask us something different. They don't ask us like how this come to calculate it. They did not tell us that. According to this model, when will the population of the United States will be 354 million? That means they said as number of population PT equals to 354. Then what will be the value of T? See how we solve it. Just we put it here and find out the value of T. We put 354 million here. Then we try to find out the value of T. How this line comes, 354 divided by 304 equals to this. Okay, we divide this number 354 by 304. Then we get this. Then we have this kind of situation where we will have to take logarithm in the both side. So when you take the log in the both side, this is something like this. You can take log also if you want, no problem. But log is better here because there is no e. If there is e, then log is better. See, if you take log, then it comes like this. Okay, both will give us the same thing, same answer for sure. So we get t equals to ln 1.65 this, and then ln 1.0 this and this. The change of base formula here, and we get this. Okay, and once we get this, then what we have here is 2025. If you do it in the calculator will give you 2025 point something, decimal something. This divided by this and this divided by this. Let me show you actually from this line how we go to the other line. So if you take log or ln something in this case, what you have, so log 1.165, then this equals to suppose log 1.009 to the power t minus 2008. Okay, then you have log 1.165 equals to t minus this is approximately, that's why we are using this sign here. This is a little bit approximated. T minus 2008, then divided by log 1.009. Then you just bring this log to this side. Okay, then this log, you can bring it to this side, then it will be plus 2008. This way, this side it will become then that division thing that you have seen, this division thing. Okay, so you can take log or ln, both of the things. B number, they asked us like if the value is 416 million, then what will happen? That means here we will have to put 416 and do the same calculation, then we will get the same answer. Different answer of course, but the process is same because the value is different, so that's why the value will be different here. That means that their population in USA will be 416 million at the year 2043. This is 2022, so let's see what happens actually. Okay, there is another math for additional practice, similar kind of math. This is for the world population modeling. Okay, that one is for population in the USA, this is for the world population. That's all for today's recording. Thank you all, thank you very much. Have a good day everyone, and see you all in the class. Okay, bye bye.